So for 5.2, we're looking at what happens when you divide polynomial functions. For today's section, we're going to look at 4 different things. We're going to look at wholes, vertical asymptotes, horizontal asymptotes, and oblique asymptotes. So different kinds of asymptotes we can get, and basically what happens when you divide polynomial functions. So first thing we'll look at is what happens, or how do you obtain a whole in your graph. So if you have x squared minus 16 divided by x minus 4, the first thing anytime you're dividing is to simplify the equation as much as possible, and then you start your division. So first thing I'm going to do is factor the numerator. I'll be left with x minus 4, x plus 4, because it's a difference of squares, divided by x minus 4. Now I see an x minus 4 at the top and an x minus 4 at the bottom. They can be crossed out. And so x squared minus 16 divided by x minus 4 would simply be x plus 4. However, because we canceled out x minus 4 from the numerator and the denominator, what's going to happen is that we will have a whole at x equals 4 because we canceled out the x minus 4. What would that look like? Let's take a look. So I know that x squared minus 16 divided by x minus 4 will just be the x plus 4 function. So I'm going to graph x plus 4, meaning I start at the y-intercept of 4, and then I go up 1, right 1, down 1, right 1, and in general this is what my function would look like. However, I have to include that there's a whole at x equals 4. So if this is 4, I would go up till 4, and I know that there needs to be a whole right there. What this means is the domain for this function is x, remember the real numbers, just like it is for all linear functions, with one simple restriction, which is that x cannot equal 4. The reason is if we plugged in 4 for x squared minus 16, we would get 16 minus 16, and for x minus 4, it would be 4 minus 4, which is 0 over 0. This is something that's called the indeterminate form. It always results in no answer. So it means you cannot plug in, you cannot get the indeterminate form. So if we plugged in 4, we would get this. Therefore, there's something different about it. In this case, it's a whole because we can cancel out the numerator and the denominator with the same expression. Okay, let's look at vertical asymptotes. So now we have another quotient of a polynomial function. We have 2x minus 4 over x plus 1. In order to determine vertical asymptotes, all you're trying to figure out once you've simplified your equation is the denominator. Whatever makes the denominator into a 0 will be considered, cannot be used, and therefore will be a vertical asymptote. So x plus 1 cannot equal 0. Therefore, we take the 1 to the other side. X cannot equal negative 1. What it would look like, straightforward, that x equals negative 1 in our function, we would have a vertical asymptote. It's not the straightest line, but it works. So now we're going to look at the 2 different types of non-vertical asymptotes that you will come across. One is horizontal asymptote, and the other is an oblique or slant asymptote. A horizontal asymptote will go straight across, whereas oblique slant asymptote will either be diagonally going downwards or diagonally going upwards. The horizontal asymptotes exist in any polynomial function if the degree of the numerator is less than or equal to the degree of the denominator. What do I mean? So if we have f at x is equal to 1 over x minus 3, for example, what you would have done in 5.1. They all have a horizontal asymptote, which is the x-axis. Another example would be if we had x squared minus 2x plus 8 over x squared plus 4. In this case, the degree of the numerator is 2 and the degree of the denominator is 2. As long as the degree of the numerator is equal to or less than the degree of the denominator, you will always have a horizontal asymptote. Okay, and what that horizontal asymptote we'll focus more on in 5.3. So for the oblique or slant asymptotes, that's going to occur if the degree of the numerator is 1 more than the degree of the denominator. So let's say if the numerator is 2x cubed and the denominator is 3x squared plus 4x. The degree of the numerator is 3, the degree of the denominator is 2. So if the degree of the numerator is 1 more than the degree of the denominator, then you have a slant asymptote. Horizontal asymptote is if the top, the numerator, is equal to or less than the denominator when we're talking about degrees. That's horizontal asymptote. If it's more than by 1, then you have an oblique or slant asymptote.